Hello, guys. I'm so sorry to not be with you today. I'm a little sick, but I hope you understand. So we're going to talk about the trigonometric functions, I mean. And if you remember last class, we conclude one and is the one of sine. Well, just the shape, made some analyze of this one. But the main idea is that I want that you see the little details that counts for this one, because then you're going to do exactly the same job as I present in this presentation in the function of cosine. And we're going to try together the one of tangent. So that's like the way we're going to do during this week. And that way we conclude everything about trigonometry of this year. Okay, so let's see what I have for you in this presentation. Well, some function normally is represented like that. In some books, we can see it like y equals sine of x. In our book is f of x equals sine of x. So it's normally the notation we use for the functions. And what we will do to understand why the shape of sine goes like last time I show you, it's that we will analyze the values and then see like the pattern they make, because at the end is what we want to discover from each of these trigonometric functions. So all the values that will help us to understand that shape and the pattern that it follows are in the unit circle. So those are the next ones. Of course, here you have the unit circle. You remember how to use it. It's pretty simple. All you have to focus on is in the relation made by the angles, in this case, working the angles in radians, and then the y coordinates of all those points around the unit circle. Okay, so here we go. And I think you're gonna have a list like this one in the Jamboard, so I will appreciate if you complete it. Of course, try to do it with the unit circle, because at the same time you're going completing the rotation, you're going to see the pattern that works over here. I'm just gonna show you like part of this one, but I want that you discover it yourself, especially with the other function you're gonna try, which is cosine. So to consider sine like a function, you need to remember that for every function, you need a set of inputs, which normally is like from where you start or with what you start in a function, and then a set of outputs, which is related with the result of the procedure made by these inputs, getting then an output result. So it's like a machine, right? This is the idea of a function. Any function works with x and y values. For this specific case, the trigonometric functions will work with angles. So you're not working like x as real numbers like 1, 2, 3. Remember, you're working over there by thirds, by fourths, by halves, okay? And it has a very important meaning. I mean, is a trigonometric function the thing you're working over there? And trigonometric functions, if you remember with the calculator, when we try it, just work with angles, maybe in degrees, maybe in radians. In this case, it will be in radians. So the function that we will make will work with angles, and that's why we will replace the angles instead of any other value. I mean, we're going to replace that by thirds, that by half, in order to create the list of values that will make that relation, or that will show us this connection of points that at the end conclude in the shape of sine. Of course, you're going to do a job similar to this one with the cosine function, because those are pretty similar, just that they have different shapes, and that's what I need that you discover, the shape of these ones. Well, here I have a summarize of all the values in the unit circle. I want to show you something. If you remember, there are 5 important values. The first 5, I'm talking about the sine, the cosine, or maybe the tangent of 0, pi 6, pi 4, pi thirds, and pi and a half. Because with these 3, I think you're gonna see then the same relation with the other values. I mean, the same answers, just that maybe going in a negative way, as I told you with the other values, right? So for example, where this sine function starts, if the unit circle starts in 0, 0 opening, or 0 radians opening, the answer that will connect with this one will be 0, because the sine of 0, as we can see here, is 0. Is it something that we have to do in our calculator? No, all this comes from the unit circle. So what I will need is that you make the list of these values in the Jamboard, but more than make the list is plot all these points, is graph all these points in the coordinate plane that we prepared the last time. Okay, so just keep in mind something, because in the coordinate plane that we made the last time, I think we made the division for the x values, for all of those x values, dividing this in pi 12s, if you remember, but we haven't made the division of this part of the top. You can make it, no problem. For example, the highest value you're gonna have over there is 1. The one that is like at the beginning over there, or the one that looks like so the half, of course, is 1/2. Then the next one will be this one, is related with a square root of 2/2. And finally, this other value over here will be a square root of 3/2. Of course, you have the same division below. So instead of work with 1, of course, you're going down in the y coordinate. It's going to be -1. The other values will be like negative a square root of 3/2. And finally, the other, which is negative a square root of 2/2. Well, here is missing the -1/2, of course. So that way you can make like that connection of the points. For example, plot the point 0, 0 is just make a simple point in the origin. But what will be the next one? Let's see what will be the next one. Next one will be pi 6, 1/2. Pi 6, I remember, in your coordinate plane, the special coordinate plane we made, that was like the second value, right? So suppose this is like this one. So you're gonna connect this one with 1/2. And that way you're going to start like making the shape of sine that, if you remember, goes like this. And let me show you something. Why it goes like this, especially with the first 5 values. Because these 5 values shows you like this part of the graph, like from where it starts until the maximum point it reaches, which is in 1, in pi half, 1, as you can see here. And then from here till the end, these 5 values will start repeating. Okay, so if you see here, you have square root of 3/2, square root of 2/2, 1/2, 0 again. Yeah, those values starts to repeat, and it is because the pattern of this one, it's like from this first part, it goes up and then starts going down, of course, in the opposite direction. I mean, it starts like in 0, goes on until 1/2, then to square root of 2/2, and then to square root of 3/2, and then reaches like the highest point, which is 1, and then starts falling down, going back from the values we have. For example, here, 1, so the value that is going back again is square root of 3/2, then falls again to square root of 2/2, to 1/2, and then to 0. What's going to happen over there is going to continue falling, because practically you complete now this other part that reaches again 0, and then starts falling down to complete like the other part it has. So at the end, it reaches like the minimum, and again, it goes like up. So it starts like going up and then starts falling down and then goes up again. So that's like the pattern we have for this function. That's what I need that you show me in that coordinate plane you make. And at the end of the job you will make for this hour will be something like this. Of course, you don't need to show me the circle. You just need to show me this connection of values and this shape of sine. What else do I need that you do with this one? Well, that you remember what was the period. The cycle is very clear. That is this one. I mean, it's the shape that we discovered that behaves sine. It's not something that you have to make again. So when we talk about the amplitude and we talk about the period, that's what I need that you do in the assignment of today. So best of luck for you. And then during the week, we're gonna work with cosine and maybe with tangent, depending on the time, but I hope to make it with tangent too. But with cosine, I will need that you try yourself. Cosine behaves a little bit the same, but it's not the same. Okay, so be careful with those little details. So that's gonna be it, guys. Make the job, please. Make it in your notebook. If you can do it in a construction paper, well, it will be better. But if you can make it in your notebook, it will be okay. Because at the end, I'm gonna add this like part of the assignment of this week. Remember that we're gonna have a classwork this week, so it will be part of this assignment. So that's gonna be it, guys. Thank you so much. Again, apologize I cannot be there with you today, but maybe tomorrow. Okay. Bye bye. Have a nice day and see you. Bye.